So, welcome Chris McDonough, mastermind behind the Pyramid Framework. Talk about Auth is hard, let's ride bikes.
Thank you. I am going to talk about pyramid authorization and authentication today. So if you are here for Django, you are in the wrong room. I know it's hard when you're out drinking late at night, but so this talk is going to be pretty code heavy. And if you have a mobile device, or you're on your laptop or something, or you have a phone that can browse, you might want to go to this URL to sort of follow along. It has sort of notes about the different steps that we're going to take as we talk about pyramid authentication. I'm going to take you through a set of steps from a pyramid application that has no security to a pyramid application that has way too much security. That URL it's probably impossible to read down there, but it's at the bottom of the screen. It's github.com/mcdonc/bikes. But if you go to github.com and search for McDonc, MCDONC, you'll wind up there. So a few principles before I start showing code. The way I like to develop web applications is to not think too hard about security while I'm actually making it work, because I'm not very smart and I need a way to actually just sort of have it work without thinking too hard about, can this user do this X, Y, or Z? And so one of the ideas that Pyramid sort of implements is that you can build your application and then sort of sprinkle on security later. And typically, the way we like to sprinkle on the security is not by changing the code that's actually in the application. We actually like to sort of change the view config decorators and the configuration stuff so that people can either execute or not execute certain views based on permissions and other fancy stuff that we'll talk about. The sort of buzzword for this is declarative security. And what declarative means is that there are no conditions. It's a system that there are no if statements in, because if statements are where bugs live. So I'm going to call these different modes of security. Most web applications have some form of security that I'm going to call global security, which means you make an assertion that some user or some group can do X. Let's say it's edit blog entries. That means that user can edit all blog entries. All right, so that's what I'm going to call global security. There's another kind of security that I'm going to call object level security, where a user can edit this blog entry, but not edit this other blog entry. And sometimes this is referred to as row level security in SQL-based systems, but not everybody uses SQL, so I just call it object level security. So a few definitions. One is a principal. Principal not as in high school principal, but principal as in a user or a group. A real person, Chris McDonough, as real as I can be, is represented by some number of principals. All right. The user Fred might be represented by the principal named Fred, another principal named authenticated, and another principal named everyone, and he might also be in a group. So he might actually possess memberships of 4 principals. So some of those principals are sort of, ad hoc groups. Some are whether he's authenticated or not. But there are a number of principals that represent a real user. A permission is a string, usually, that is more or less a verb that says what someone can do within a piece of code, usually a view. You usually protect a view with a permission. So delete, edit, view, etc. Different frameworks have different definitions for this stuff. Different framework might say a permission is editor, instead of edit or something. And this is pyramid specific jargon. So just so you know. Okay, so I'm gonna show some code from here on in. There will be no more slides, well, except for the end. The first bit of code that I wanted to show you is a very simple application with no security at all. When we run this application, and you visit blog 1, okay, I don't know if everybody can see that URL, but it's localhost 8080/blog/1. There's no actual logic in this application. It's just sort of, okay, pretend this would show a blog entry of some kind. And when you go to blog 1 delete, it will delete that blog entry. Okay, that blog entry is now deleted. This is all this application does. It has no security at all. Anyone can view any blog entry. Anyone can delete any blog entry. That's the whole point of it. So I'm going to go on to another one. So I'm going to just for fun here before I go on, I will show you the sort of view functions that do this. Here's the thing that shows the show view, and this one that's number well, both are number 1, sorry. But the second one is the one that shows the deleted one. As you can see, they're very simple. They don't do much. In the bottom of this thing, we just have stuff that adds routes for those things and configures them. So I'm going to move on to something that actually does some security. Okay. I'm going to go on to a slide to a system where we actually are wiring up a login and logout view. Down here, we have config.addRoute login and config.addRoute logout. And those are two views that are defined up here. The login view gets a user ID out of the get parameters. It's like $user ID equals Fred, or whatever, and sets some headers in the response to set a cookie. And that cookie says that, okay, this guy has a cookie that says his user ID is Fred, no worries. And we also have a logout view that does the inverse. There's no way to unset a cookie, explicitly. There's no unset cookie header, so you have to expire the cookie. So it's a set cookie header that expires the cookie. So we can now log in and log out. We don't do any, in a normal application, we would do some password checking here or something. But for the purposes of this demonstration, imagine that the login view checked that the user had supplied a correct password, okay? And the rest of the application is exactly the same. Here we have a show view that I need to take that line out of. And it just shows a blog entry. And we have a delete view that deletes the blog entry, but we've added a little bit of hair here, this code, that grabs that user ID that we set in the login view, and if it is none, if the user is not authenticated, we raise an HTTP forbidden error. And we'll see what that does here. So now, I'm going to do the same thing. I'll go to the show view, and we can see that still works. But if I go to the delete view, oops, let me log out first. If I go to the delete view, we get a 403 forbidden error. Now we can customize this view. This is just for purposes of demonstration, pay no attention to the ugliness behind the curtain here. But the point being that we've added a bit of security to our application imperatively. We've changed our view, our delete view, so that it does something different, okay? And this is a reasonable form of adding security to your pyramid application. All right. The nice things about it, there are no frameworky bits to this application. It's all your code. This doesn't use the pyramid security subsystems. But it is a reasonable way to do things. If you just cannot figure out security, you can do this all day long. It's not really a problem. Okay. Now the problems with it are that the way we're doing security here is that we've married ourselves to this cookie-based authentication and authorization system. If we want to add another view to this system that is not delete, something that lets you edit a blog entry, we're going to have to repeat this little bit of code here, get this cookie, if the user ID is none, raise forbidden. We're going to have to do that all over the place. Pyramid has some bits that let you elide that we'll see in the next step. Another thing here is that logically, in life, authentication doesn't depend on authorization. Okay, you can tell someone who you are, and that doesn't mean that you have the rights to do anything. Okay, but authorization depends on authentication because someone typically gives you the rights to do something after knowing who you are. But in this application, we sort of have them mixed up. They are not independent of each other. We are married to this cookie-based authentication system everywhere. We can't just say, okay, I don't want to use cookies anymore. I want to use Kerberos because this very basic stuff is sort of spot welded all over our code base. So I am going to go to the show you how to do this in a sort of more pyramid-y way. We're going to run app 3. Now, nothing about the application is going to change. Exactly what happened before is going to still happen. And the code is going to get more complicated. All right? So in this application, in this version of the application, we have added down here, somewhere down here, a couple of lines that add an authentication policy and an authorization policy. The authentication policy determines who you are. The authorization policy determines what you can do. Okay? They are different axes, and they work together. The only requirement is that if you have an authorization policy, you have to have an authentication policy in Pyramid. But we have implemented our own authentication policy and our own authorization policy. And instead of we pass these things into the configurator as those those authentication policy and authorization policy. And instead of in our login view here, instead of setting a cookie, we call this remember function. And guess what this does? Does anybody have any idea what this does? It returns some headers that set a cookie. Exactly. So we've just abstracted the authentication bit out into our policy, out into our authentication policy. This remember function finds our authentication policy and calls its remember method. Okay. So I'm going to take a look at our brand new authentication policy here. And we can see that that is exactly what it does. Our policy has a remember method that takes some number of arguments and returns a cookie, a set cookie header. Okay, it does a bunch of other stuff too, but that's not much different than what we did before. The log out view in this application calls an inverse function named forget. And does anyone want to guess what forget does? It does exactly the same thing, except it calls the forget method of the authentication policy. So all we're doing is abstracting the authentication policy, the authentication of our application out into this policy object. And when we do that, all of a sudden, this code, if we decide to do something slightly different about authentication, does not need to change. Okay, if we want to do Kerberos auth or basic auth or whatever. There's a bazillion of them. We can change our policy and our code that does the cookie setting. We just need to swap that out for something else, and our actual view code does not need to change. So we've made that abstraction. So another thing that our policy does for us is it lets us abstract the protection of our delete view. So if you notice here, we didn't have this line in our delete view before. It's a permission. It says delete. What it means is when this view is executed, only allow the views, or when Pyramid attempts to execute this view, only allow the view's execution if the executing user has the delete permission. Okay? The executing user is is not just, sort of an abstract concept. The executing user is the set of principles that we talked about at the beginning of this thing. And the authentication policy is also responsible for computing the set of principles that are associated with a user. Okay? In this case, every principal is a member of the everyone principal group. A user has a user ID, and that becomes another principal. Every person who has a user ID is a member of the authenticated group. And in this case, when we log in, we are going to be a member of at least 3 principals. We're going to be everyone, we will be authenticated, and we will be Fred. Okay? So when I go over here and I log out, just to make sure, and I log in as Fred, Fred is implied by that set of principles. And we also have this other subsystem in here, which is an authorization policy that is our own code. It doesn't inherit from anything. There's no magic going on here. All this code is all your code. But it implements an interface. One of the interfaces that it implements is called permits. And basically, this thing gets called when a view is about to be executed. It gets past a context object, which we're not going to think too hard about right now, but it gets past the set of principles that are returned by the authentication policy. Remember I said that authorization depends on authentication. And it gets past the permission that protects the view. So when I want to go execute this delete blog thing, it will be past a set of principles, which are everyone, authentication, and Fred. The permission will be delete, okay? And the logic inside of this permits method says if the permission is delete, if the user is authenticated, return true, more or less. Otherwise, return false. Okay, so because Fred has permission to do this, when I try to go to the delete view, he can. But if I log out, I'm no longer Fred, I'm just everyone at this point. If I go to delete, I get it forbidden. So this is all, if you want to customize your application with sort of global security, I would suggest trying this out. I would suggest, if you don't need row level or object level security, this is probably a pretty good way to do it. There are a number of existing authentication policies in Pyramid that you probably want to reuse. You might want to reuse the existing authorization policies, but you don't necessarily have to. Okay, but you almost certainly want to use the authentication policies that are in Pyramid for this. So, everybody's head spinning at this point? Okay, so I'm going to move on to another one. I'm certain I'm going to run out of time to display every step here, but in this app 4 is exactly the same as app 3, except we do exactly what I just said. We ditch our custom authentication policy and use one that is built into Pyramid for that purpose. So we no longer have code in there that implements this thing up here that we have in app 3, our dumb authentication policy. It disappears in the next step. And instead, we use this thing called an auth ticket authentication policy. Okay? And basically that is a pure swap. There is no other change to this thing other than just removing our dumb authentication policy, swapping in one from Pyramid. And this thing does almost the same thing as our dumb authentication policy does, except it sets a different kind of cookie. All right? And it has a little bit of hashing going on with a secret, so that we know that the guy hasn't tampered with his cookies. All right. So if you just have global authentication, or you just have global authorization needs, this is probably where a good place to start. All right. This application works exactly the same as our last one. I won't even show it operating because it's exactly the same. Pyramid has a couple other authentication policies, the session authentication policy, a basic auth authentication policy, remote user authentication policy if Apache controls your security. So this is a good place if you need sort of, Django style or other web framework style authentication. You want to wind up here. I'm going to move on to the next step, which is app 5 here. And we're just going to make a slight change to our app 4 stuff, although this is typically, I think, where people go off the rails about how to use pyramid security. We are going to start using, instead of our dumb authentication policy, we're going to start using another feature of Pyramid called the ACL authorization policy. So we've ditched our code that implemented the dumb authorization policy that did, if the permission is delete. That is a terrible 5-minute sign. If the authorization policy is delete, if the permission is delete and the user is authenticated, allow the action, otherwise do something else. We've replaced that with this built-in ACL authorization policy. And what happens here is, in order to make use of this ACL authentication policy, we actually have to start using what's known as a root factory. And you are permitted to freak out. But we pass this root factory object into the configurator, and every time a request comes to our application, an instance of this root factory object is created. And there's only one of these things, but it has an ACL attribute on it that says what can be done when this root factory is the context of the view. And I imagine I'm not going to be able to explain that entirely, but basically, in this case, the context of the view is always going to be the instance of this thing. Okay? So what we're saying here is allow authenticated to delete something. All right? We are not using our dumb authorization policy anymore. We're using the ACL authorization policy. It is the thing that needs this root factory. And guess what? Our application does exactly the same thing. Okay, we've just moved this statement into this root factory, given it an ACL. The ACL authorization policy looks at the statement here and says, okay, I'm going to allow authenticated users to delete, and I will not allow anything else. One of the important bits of what we've done here is we've removed every bit of conditional logic. This is all declarative code. There are no bugs in this application caused by you typing, more than likely. All right? And that's pretty powerful. That's a powerful thing. So I have 2 more. How much time do I have left, Blaze, you think?
Almost 5 minutes.
Okay, good. So I'm going to try one more step here. So in this step, it's basically the same thing as the last step, except all we've done is we've changed this ACL here from allow authenticated to delete things to allow Fred to delete things. Okay? So if I walk up to this application and I log in, if I try to delete something, it won't let me. If I log in as Fred, it hopefully will let me. Yes. But if I log in as Joe here, it does not. Okay, that's the power of having ACLs and being able to change those things. In other systems, these contexts, the things that are produced by root factory, the state of the root factory objects may live in a database. It might not live in code. Okay, so you can sort of dynamically change ACLs and move stuff around. Okay, so quickly, we're going to try to tackle the next step. This is probably too much. This is probably 10 pounds in a 5-pound bag, but we'll do it. In this next step, we have a root factory that produces a resource, a root object, but that root object has children. It is a tree of things, all right? And the tree contains exactly one sub-object. Sub-object is named 1. So in this tree there is a root object, and it has a child named 1 in here. And what this lets us do is we can compose what's effectively a sitemap for security in our application that lives under the hood here, that is produced by this root factory, that lets us make different assertions about the security in one part of the sitemap that are not in the other part of the sitemap. In this case, what we're saying here is that in the context of, in the sort of sitemappy context of this one object, authenticated users are allowed to delete things, but at the root, they are not. Oh, okay, I will give up. Sorry, if anyone has questions, they're welcome to see me later. I apologize for not timing this correctly. But again, all the stuff that I talked about is actually in these slides, so you can get online and read them and punch me in the face later if you want to. So thank you very much, appreciate it. I'll take questions now.
We have like 5 minutes for questions, so if we have a question, just go to the microphone and you can ask question.
Good.
Can you test the location of the slide here?
Yes, sure.
Meanwhile, can you tell us quickly an overview of how to integrate other auth systems like, say, OAuth or OpenID? How do those things plug in? Thanks.
Sure. There is a system named Velrus that is, I think at this point it actually requires Pyramid, but it's actually more general than that. It's sort of something that just happens to use Pyramid to do that stuff. And it has authentication. Well, I'm probably wrong about this actually, but it definitely has sets of event handlers that will allow you to produce successfully logged in users based on Twitter stuff and GitHub stuff, and it's got a bunch of providers in it. So that's probably the place to look. It has pretty good docs. So and it plugs into Pyramid nicely.
How do you spell Velrus?
V-E-L-R-U-S-E. Sorry. There's the URL up there if anybody needs it. Any other questions?
I'm just wondering, maybe it's if you have the object level security, does that imply only traversal, or is it URL dispatch also?
Well, sort of a little known thing about Pyramid is that when people use URL dispatch and they don't need to think about traversal, but actually traversal always happens. So when you are using security in this fashion, you are making use of traversal, but you can use it along with URL dispatch as the traversal tree is actually just the security tree. And you say, this view is associated with this traversal path, sorry, this route is associated with this traversal path, and when traversal happens, it comes up with a context that has an ACL. So I wish I had had more time to show that actually. All right, well, thank you very much.